Okay, so this is what we call a rational expression. It's a fraction with polynomials. You might also see the definition as a ratio. So anytime you have a polynomial in the numerator and a polynomial in the denominator, it's called a rational expression. You guys, again, you could have like the 3ab over 12ab, like that is also a rational expression. And we talked a little bit about a complex fraction where you have a fraction over a fraction. That's a complex fraction. So we also are going to do some factoring today, and then we're going to talk about restrictions. Okay, so now we're going to factor, and we're going to talk about restrictions. So here is the problem. I'm going to use paper because those little boxes and me don't get along. Okay, so the top one, is that factored? The numerator is completely factored, so we're going to leave the numerator of the fraction alone. Is the denominator completely factored? No. So we're going to write y. And we're going to think of two numbers that when we multiply, we get -6. And when we add them, we get -1. And the reason I can do it that way is because the leading coefficient is 1. So what are two numbers you can multiply to get -6 and add to get -1? Okay. So y minus -3, y plus 2. Now before you start reducing and all of that, what we need to do is we need to write our restrictions. And basically a restriction is, where is the domain undefined? So restrictions are, where is it undefined? Now we're going to use these restrictions later in section 8.3. Okay, so the first thing, anything you do with rational expressions is you factor it and then you list your restrictions. So my restrictions are purely based on the denominator because that's our domain. And remember, when you put your domain in, you can't get an error when you're doing it. So we're going to set that y equal to 0. We're going to set this y minus 3 equal to 0. And we're going to set y plus 2 equal to 0. This one's done. So if we put y in for 0 as our domain, and we would get an error. So it is undefined, so this rational expression is undefined at y equals 0. What does y equal here?
3.
So if we plugged in 3, we would get 0 in the denominator, and that would make our rational expression 0. And what would we get here? Again, if you plug -2 in, you would get a 0. It would make your denominator 0. So these are our restrictions, or where the domain is undefined. It means that you would not be able to plug in these numbers and actually get an answer. Okay? Now, when you go to reduce, everything has to be identical. Okay? So inside parentheses, they have to have the same variable and the same operation sign. So y minus 3 over y minus 3, those cancel out. They're identical. Now, you can't just cross out y's and 3's. You can't multiply anything. If they have addition and subtraction, it matters, okay? Y plus 4 and y plus 2, they don't matter. But see how the y's are on the outside of 4y and a y? They're on the outside of the parentheses. Those we can reduce. So these y's, they cancel out, and we're left with 4 times y plus 4 over y plus 2. And that's our answer. What questions do you have? None? Okay, let's go to the second problem. Okay, here's our second problem. Do you guys have it written down? So just like we did the last time, the first thing that we need to do is we need to factor it. Even though the denominator is completely factored, what we want to do is factor it first, and then we'll list our restrictions. So 2z is fine, z plus 5 is fine, but can we factor z squared plus 2z minus 8? So like I said, 2z is fine, z plus 5 is fine. Can we think of two numbers that we can multiply to get negative 8, and when we add them we get 2? And is one of them negative and one of them positive? 2 is negative and 4 is positive. Okay, so now we're going to state our restrictions, which means where is this rational expression undefined? Okay, so is there anything that we can reduce with the 2z? Like, is there a z on the outside or a number on the outside of the parentheses? No, so we're going to leave 2z alone. Is there a z plus 5 that I can cancel out in the denominator? So remember, z plus 5 is an entire entity. So we're going to go here and we're going to go there. Okay, so z minus 1, oh man, I started a conversation and then I didn't finish it. Z plus 5 equals 0. And z minus 2 equals 0. Before you start crossing out, you guys, like I did because I got really excited, you need to set your restrictions. So z minus 1 equals 0, so what does z equal? Here, z plus 5 equals 0, so what z can't be? Negative 5. And on this one, z minus 2 equals 0. 2. These three right here, we're going to use those, but that means that if I plugged in any of these numbers into this rational expression, it would be undefined. My range would be undefined. I can't have that. Okay, so now let's go back to reducing. So these are my restrictions. Do I have a 7 minus 2 somewhere? Here and here. Now, do I have anything else that can be reduced? Like, is there a z plus 4? Is there a z minus 1? There's not. So my final answer is going to be 2z times z plus 4 over z minus 1. Now, you can leave the parentheses around it if you want to, or you can leave it as z minus 1, but this is your final answer. And you guys, you can't multiply it out and then cross out the z's. Remember, z minus 1 is an own entity. It's a number, okay? What questions do you have?